Hi, everyone, and welcome to the third Oracle ACE live session. My name is Juana Bonu, and I'm the community manager of the Oracle ACE program. I'm truly excited to have you with us today for this session of the ACE Live webinar series designed to bring world-class expertise, fresh perspectives, and real-world Oracle insights directly to the global tech community. For those of you who might be new to the Oracle ACE program, I'd also like to take a moment to introduce what we're all about. So the Oracle ACE program is Oracle's external advocacy program. It's an initiative that has over 20 years. And hopefully I can go to the next slide, but somehow, okay, I think now I can. And it has over 600 active members in 59 countries from all over the world. So we are talking about developers, DBAs, IT leaders who regularly share their insights through blogs, podcasts, conferences, and a lot more. So our Oracle ACEs not only stay on top of our latest Oracle technologies, but they also inspire others to learn, to connect, and innovate. We are also very happy to launch the Oracle ACE Apprentice Level. This is a new initiative that we announced this year at AI World, and we are happy to bring it to you here as well. So what is the Oracle ACE Apprentice Level? It's actually a beginning level with a learning path into the program designed for those exposed to Oracle technology as part of their day-to-day roles, if they have new roles, or for people who use the products on their free time, or even for those who are recent graduates just starting their careers and have a focus on Oracle. For that, we have created a dedicated learning path, and we have a series of resources for them, training, all the help they need from us and from our Oracle ACEs to become proficient, to sharing to learning and to share their knowledge. And for that, they need to register to join. It's a bit different from the current levels where you submit a nomination and it is reviewed. For this one, you need to register. And if you pass the compliance review, then you are free to continue your learning path and your experience with the ACE program. Of course, we have some benefits per level, just quickly showing you an overview of what you can get if you join us in the community. But I do not want to spend too much time on that, and I want to leave Stefan to present, because that's why we met today. I do want to welcome you to go to ace.oracle.com/apprentice or ace.oracle.com/join to learn more about this new initiative, pre-register or pre-register or actually submit a nomination for one of the other levels, right? If you are already an active contributor and you want to join us, you can submit a nomination there. All right, and of course you can connect with us on any of these channels, and please join me in welcoming Stefan, who is an Oracle ACE director. I'm going to stop sharing while he shares his screen. He has been working with Oracle database administration, security, architecture for over 20 years. He has held key roles at Trivadis and Accenture, and he's widely recognized as a speaker, author, and community contributor. So today, Stefan will be taking us through his session, TDE Demystified. So let's give him a warm welcome, and thank you again for joining us for ACE Live.
Hi, from my side, I wish you a great evening or a great morning, depending where you're located. And a warm welcome from Switzerland. Here it's a bit foggy, no sunshine, usually the weather of this season. So let's dive into the topic of today. I have a couple of slides, I think a bit too much for this session, but we'll see how far we get. So I will give you a short introduction to the topic, to the security topic, why we do TDE, why we want to encrypt something, short overview on TDE, what's behind TDE or what we are doing with TDE. Then we discuss an important part, how we do the key handling. We look into a few use cases. I will show you the methods how to deploy TDE. We will also discuss other key management options beside the key store, and I give you a few ideas and best practice if you start your own encryption project. So it's really everything in one presentation about TDE. I try to cover quite a lot of things to give you an easy kickstart to this topic when you want to start your own encryption projects, or if you're already doing encryption on your database, that you have another point of view in this topic, probably a new ID for your project or for your database daily work. Yeah. So why we do the encryption at all? So basically, it's the important part that the data within the database is usually your crown jewels of your organization. So they're quite important, and there are a few parties which would like to access this data or which get information about this data. It can go from criminals, activists, it can also be competitors, but it can also be former employees or curiosity seeker which try to get access to your data. Yeah, and we have to distinguish between external attack and internal threats. I don't spend too much time on this, so let's see the different attack vectors. So if we have a database in the middle, then we access the database via network, but there is a possibility that data and information can be visible to external parties or to other people if they access the data directly on the system. If your storage vendor can access the storage system and you don't want that they can directly access the data, if it's on premises or if it's in the cloud, you're interested that your data is encrypted at rest, and that's all about TDE covers mainly the encryption at rest. So just at a glance, if I put one of my favorite slides where I put all the database security features. So if you do not yet know what kind of database security feature you want to use, that's the slide where you can start with. You see all the features you have with Oracle within the Enterprise Edition. Some of them are available in Standard Edition, but also third-party products. Also additional products like Database Firewall, like the DataSafe cloud service, and so on. But today we're just talking about the lower right corner. So we just talk about the data encryption, so the transparent data encryption, and also possible key management system using HSM or Key Vault. When we talk about TDE, there are basically two different ways how we can encrypt data. We can either encrypt the whole table spaces, or we can encrypt columns. In this picture, you see a database and a column. So this red table has a column encryption enabled, and we see it is always multi-level or multi-tier key management. We have keys for this table within the data dictionary, and this key itself are then encrypted with a key which is outside in a key store. And this is the master encryption key for this particular table keys within the database. So we have an external key and we have a key within the database. And that's for column encryption, where we just encrypt one certain column. But today it is much more use. It is usually more that customers are using tablespace encryption, because you do not have restrictions on data types and indices and so on within tablespace. So with tablespace encryption, the whole tablespace is encrypted. And also here we have the external key store with the master encryption key, which does encrypt the tablespace key, which is within the database. And so the database needs the external key to decrypt the tablespace key and to decrypt the blocks of this particular tablespace, which is encrypted. So you see already there are more different aspects when we start using TDE. And that's the first point There was a story once in Switzerland that there was a government department in Switzerland where somebody started to encrypt data on a database, and he just took the key and left the company, and then blackmailed the company, say, yeah, if you want to access your data, I have the key. So that's the really the Achilles heel of TD. You have to know your keys. So you don't just have to encrypt the database, you have to know what you do with the keys. You have to make sure that you have them, that you know how to access them, that you back up them, and that's the most important part. TDE, as it says, is transport data encryption, and it's basically quite simple to implement it theoretically. But if you do it something wrong, and if you lose the key, then your data is locked within, you say, a safe here, and the DBA or the people cannot access it anymore. So let's see what's about this key and master encryption key and these different things. We have a couple of concepts within TDE. With Oracle, over time, there have been different names been used. In old times, we were just talking about the wallets. Basically, it's still the same file which we use to store this master encryption key, and depending where we look into the documentation, it's still called a wallet. And depending for what you use this file, it is also still called the wallet. But when we talk about TDE, we also talk about software key store, and that's the equivalent to the wallet. So the software key store is a physical file on the operating system which maintains or which keeps the master encryption key. There are usually two files. There is the e-wallet file, so the password, if you use it password-based, or if you want to use it auto-login, we will see later on how this works. There's a second file called C-wallet. So these files are located on the OS and used to get access to the master encryption key. Then we have something else called the hardware key store, which is usually, only in old times, it was HSM, hardware security module, which used the PKGS11 interface. So the database can then store the master encryption key within an ASM. We have a new product, or it's not new anymore. It's available quite a couple of years now. That's Oracle Key Vault, which is also a solution to manage key. And we will later on see why Oracle Key Vault could be an interesting solution if you want to use TD together with multiple databases in a more complex environment. Beside this terms software key store and hardware key store, we also talk about other things in multi-tenant environment. It's called united versus isolated mode. So this software key store can be used in a united or in an isolated key store mode, which is nothing else than in a united mode, you have just one file and all the keys are stored in this file for all your databases, so all your pluggable databases. The isolated mode is then that you have a dedicated key store for your PDBs, that you can store your key for your PDB1 here on the picture. PDB1 has its own key store, and the CDB has the other key store, the red one. So then you can do a tenant configuration, so you can give away the responsibility for certain key management things. So that's basically also what's used within the Oracle Cloud with Autonomous Database. If you have the keys, then you basically have an isolated key store for your pluggable database within the cloud environment. And to make the whole thing a bit more complex, you can also combine the united isolated mode. So if you have 10 PDBs, you can have one PDB which is in isolated mode and all the others in united mode. So you can make it as complex as you want. Here a bit, once more slide, mostly I talk about it. So the united mode is one file, keeping all the master encryption key for the different PDBs and the CDB root. That's default. If you don't change anything, that's the common way how it is used. And then there is also the isolated mode. And the isolated mode is you have to be careful. So if by default it is not enabled, but if you start to explicitly set the init aura parameter called the TDE configuration on a PDB level, this particular PDB starts to have its own key store. So I had once a customer where we accidentally set TDE configuration, and we ended up with a dedicated key store for this particular PDB. That's not a problem. You can merge it again afterwards. You can reset it. It is just important that you know it, that you have it, and that you know it when you do the backup and management of your keys, that you know that you have a dedicated key. But you can enable it, and if you accidentally set TD configuration, you can also set it back to isolated mode or again back to united mode and vice versa. Then there's something else which is important. It has been introduced with Oracle 19. If you start to play around with TDE in early days, Oracle 11, 12, 18, you were using the SQLnet Aura file to specify the location for the key store. There was an SQLnet Aura parameter called encryption wallet location, and also one called wallet location to specify the key store for TD and also for SSL certificate and secure external password store. And starting with Oracle 19, it is highly recommended that you use the init Aura parameter called wallet root. The wallet root is then defined on a CDB level, and all the corresponding wallets are then located below this wallet root. You see on the right side a structure, how this looks like. Then Oracle is then storing this, or is looking for the TD wallet below, directly called TD. And if you create a secure external password stored wallet for TD, then it has a different folder, and there will also be folders for enterprise user security, TLS, and so on. And beside this, it can also be on ASM if you want to have it not on the file system, if you want to have it on ASM as well. So that's the old one, deprecated. You still can use it, but it's highly recommended that you change your configuration to use wallet root and TDE configuration rather than encryption wallet location. Because one of the problems was that if you use encryption wallet location and you have multiple database instances on one server, all the instances were using the same parameter, the same SQLnet Aura parameter, or you have to set a dedicated SQLnet file per database, or you have to add an environment variable to the path specified within this valid location. So it was a bit complex not really complicated. You just have to be careful if you want to share it, if you have multiple databases. And with the new wallet root parameter, it's really straightforward, easy, static init Aura parameter for this particular database. You can set it, restart the database, and then you can start using TD on this particular database. You see here also a Metalink node, which explains how you can convert from a classical encryption wallet location to the new parameter, which is basically straightforward. So if you start with a software key store, then we usually have a password-based key store. This means that every time we want to use the key store, we have to open it explicitly because it's password protected. So we have to run administer key management set key store open and open it. Then we have full access to this particular key store. Usually you don't want to add a password when you restart a database. That's why you probably have or start using auto login, which means that you create a second file, the C-wallet file, and then the database can automatically open the key store and read the information within. The important thing is that if you set it to auto login, it is read-only, so it just can read it to start decrypting your tablespace to get access to the master encryption key, but you cannot modify contents within the software key store. And we'll see this later on then, because you have to use a dedicated parameter for this. And there's also a third option. You can keep the password-based access and say, I don't want to have the auto login, but I don't want to specify all the time the password when I do an administer key command. You can specify a so-called secure external password store for this software key store, which is nothing else that you basically store the password of the key store in a C wallet file, and then you can easily access it during command execution. If we use auto login, there are two ways how you can use auto login. There is the regular one, I called, and the auto login local. The difference between it is that if you have an auto login local, somebody can copy your C wallet file and E wallet file, put it on another system, and start using it without knowing the password. That's quite a risk. If somebody can get access to this file, he can use it, and he can then also decrypt your your tablespace, get access on your encrypted data, and so on. If you want to make sure that this cannot happen, you can use the auto login local, which means nothing else that Oracle stores a couple of system information within the C wallet file. And if somebody then moves away the C wallet file and the E wallet file on another system, then Oracle will ask for the password to set it to auto login again, because it says, hey, it has been moved. I'm not on the original system anymore, so you have to specify the password. You see on the bottom of the slide also the fourth key store. We will see later on when we see the commands what's behind this. I know it's already on the slide. Yeah, auto login, as I mentioned already a couple of times, it opens the key store read-only. This means that Oracle can read it, or particularly can read the master encryption key to start decrypting your tablespaces, but you cannot perform any modification, like import a key, create a new key, or doing any other change which does a change of your software key store. If you want to do this, then with your auto login key store, you have to explicitly specify force key store, which does nothing else than override the read only mode. So basically, the backend Oracle just open the wallet read write, and then it can do the change. And you see the command here, because I don't specify a wallet password. You see, I run an admin key management set encryption key, and then I use force key store, which means please override the auto login read-only mode. And then I specify identified by external store, which does nothing else than using this secure external password store, which I create separately with a password of the software key store. It sounds a bit weird, but we'll later on see how the commands, how to set up this key store, then it will be a bit more clear. This, for instance, is perfectly nice if you have automation, Ansible stuff, want to do something, want to do some key management, then you can make sure that you don't have to specify it all the time, the password somewhere in any Ansible workflows, for instance. When we talk about auto login, we haven't yet talked about HSM and OKV, but I just want to let you know that it is also possible to create some kind of an auto logging mode when you use either HSM or OKV. At the end of the day, you just create a secure external password store or a key store with the password of the HSM partition or the Oracle Key Vault, that Oracle then reads the local wallet, and in the local wallet there is no master encryption key. It's just the password which is used to access then the OKV or the HSM. So basically it's some kind of auto login, but at the end of the day Oracle is just temporarily using the credentials stored locally, and it's configured this way that you set the TDE configuration, key store configuration, not just to HSM or OKV, you add also file, which means then Oracle can access the software key store, get the credentials, and then access HSM and or OKV. So let's dive into a few examples. So we now set up a software key store. So if we have configured the database wallet root parameter and we configure TDE configuration parameter and set it to file, database has been rebooted, and now we can start to encrypt, to start with enable TDE and to start to set up the key store. The first thing is that we create a key store, software key store with the command administer key management. I specify the location. And then I create a secure external password store, which means that I define the password. It's now lab42soup25. So that's the password of my key store, and this is then stored in this secure external password store. And on the next slide, you then see that I don't have to specify anymore the password of my key store. Just can run administer key management set key store open, identified by external store. If I want to enable auto login, then I have to explicitly specify it so that there I cannot use external store anymore. I really have to specify the password. When I want to create a master encryption key, then as the last command, then I can use the external store again. So what happens if I lose the key store? That's basically full data loss. So if you lose the key store, if you really lose it or it's corrupt, then you have a problem, because then you cannot access your encrypted data anymore. If you're lucky, then the database is still running, and the database has not yet created a heartbeat to the software key store and has not yet realized that the key store is not there anymore. Then you probably can access the data. But as soon as the database realized that the key store is not there anymore, you cannot access the data anymore. So that's really a huge issue, and you cannot undo this. So it's really important that you have a backup of it, and that you also have the password. There is a small workaround for a special use case. So if you lose the key store password, so if you don't have it, but you have auto login enabled, then you have an easy way how you can work around this issue. I had the customer, they migrated around 800 databases to XRCC, and during the migration, they realized that they don't have the software key store password anymore for about 100 databases. And how you migrate databases if you don't have the password of your software key store? Yeah, you don't migrate them, or you can work around it. And the workaround is quite simple. You create a new empty key store where you know the password. And because you have auto login, you can then use administer key management merge key store. And then you merge the old key store into the new one. And because it's auto login, Oracle can read the information and store it in your new key store. And from then, you're going to use the new key store which you created, and the database is happy, and TD is working fine, and that's good. There's also something important, that if you probably have a DBA in your team which played around with TD or with keystore a while ago and on your database, and you forgot it, you throw away the keystore, you never use the TD, or you decrypt the tablespace and or encrypt and decrypt the tablespace again, or you don't have any encrypted tablespace anymore, but you just throw away the keystore, and now you want to start over again. Then you run into an issue, because the database remembers that it once had a master encryption key. And to work around this, you can set a hidden parameter and say db discard lost master encryption key to true, and then you can create a new key store and a new master encryption key. But that's really important, that you only do this if you know what you're doing, that you know that nothing is encrypted, and that you just want to start using TD and create the new master encryption key. So that's really important, and it's highly recommended that you probably, if you run into such an issue, that you probably also create a service request. Something else, had another customer where we use software key store, and we developed an ID to set up an automated backup. The DBA, they did not have OS access directly, but they want to have an a backup of their key store. And what we did there, we did use DBMS scheduler. We set up a corresponding program and a schedule and a job to create a regular backup of the key store using admin as a key management backup key store. So that was quite simple approach, and they create a copy of the key store. So the database itself creates a copy of its software key store. Same customer, we also discuss segregation of duty. They say the DBA is not the key manager. They had a dedicated key admin for this. And we implemented a solution that the DBA just creates the configuration, means the wallet root configuration, and the key admin had syskm role and could access the database via syskm and use the admin as a key management commands and create a master encryption key and so on. And so this way they could separate the task of key manager, access to the software key store, and the DBA on the other hand could then start to encrypt tablespaces without even having access to the key store. It means to have the password of the software key store. But at the end of the day, it's quite challenging, in particular when you start to do database cloning, when you start to use data guard or even drag, because all your other database, they must have at least temporary a copy of your key store. Otherwise, they cannot recover the database if you do a cloning, or the standby database also must have a copy of the key store. Otherwise, they cannot apply the redo logs. And also the rack database, they access all the same encrypted tablespace. That's why also they need to have access to the key store. In this case, usually you probably store the key store anyway on HSM. For this particular custom, we did develop a recur operation process where they say, yeah, we're going to do a rotation of the master encryption key. You see here the task for on the primary database and the standby database. The DBA did some work and the app owner did some other work. And at the end of the day, the DBA did the preparation. The app owner, with the password of the key store, he created an external key store, and then the DBA could do the task, making a backup, create a new master encryption key, export the key file, copy to the standby, restart, redo apply, and then the app owner again deleted the external store, and the DBA could make sure that he created the work on one side and copy over the key store to the other side without knowing the key store file. And for this particular customer, it was okay that the DBA could do his work without having the information of the key store password. So it was compliant to their regulations, and they were happy. But you see, it is relatively really complex, and I definitely say when you're at this point, then it's highly recommended to start thinking about the central key management solution, which we discuss later on. But before we discuss the key management, we would also look into how to enable and deploy TDE. I mean, we now have the key store, the software key store, but we would like to encrypt the tablespaces or the data as well. There are basically a couple of methods to do this. The easiest way is when you start from scratch, you create a new tablespace and you say it has to be encrypted and everything is fine, because then you can do it quite nice. You don't have to care about any online, offline encryption we see later on. You don't have any downtime and so on. You just create a nice new encrypted tablespace and you start using it. If you, for instance, anyway plan to reorg your database and so on, then it's probably a good time to create new encrypted tablespace. Then you do a reorg, export, import, alter table, move, whatever. That's really nice. And that's basically a good thing when you anyway plan to do this reorg, or when you do migration from to a different OS to the cloud and so on. But in most cases, you have an existing database and you need to encrypt it. And there are two ways to encrypt existing tablespace. Has been introduced with Oracle 12. There is the online encryption, so you can online encrypt either a tablespace or just one data file. You just say alter tablespace user encrypt online, and then it starts to encrypt it. In earlier release, you also had to specify the file, the new file name. It's not needed anymore. The tablespace will be encrypted in the background. It will take a while, but it is not really visible how long it takes, and that can be the challenging part. Oracle organized this in a way that this will be done in the background. You don't have any downtime, but it use resource on your system, because if you have a system which has I/O, which is I/O bound, then you have additional I/O because it's doing the encryption, and it can be relatively long. And it's an important thing. It is single threaded on what you execute. This statement here shows all the tablespace user, and if this user tablespace is 100, I don't know, 500 gigs or 10 terabyte or 1 terabyte, then it just runs on this tablespace. There is no parallelization. I can parallelize it on file level. So if this user tablespace has 10 files, I can encrypt each of these files in parallel, starting different SQL Plus session and starting different alter data file encrypt statements. So I can parallelize it a little bit, but this doesn't work if you, for instance, have big files. Then the offline encryption, it's nice, it's a bit faster, but it requires downtime. So you do take the tablespace offline, start to encrypt it, and then you take it online again. You can also do this on standby databases. So you can encrypt the standby database first and then switch over and then encrypt the new standby database. It's also nice, but it requires downtime. And if you have a standalone database, it's definitely a longer downtime. And also here, you can maximal parallelize it on file level. But what happens if you have a very large database? Means that they probably use not just 32 gig files, that when you start using big file tablespaces. For instance, if you have a nice tablespace around 50 terabytes or even more, then you have a problem, because then this online or offline encryption runs sequentially on this 50 terabyte file, and this can take really a while. There is a patch available for, I don't know for which Oracle 19 release it is, and when it's now in the main branch, Oracle improved this a little bit, but at the end of the day, it is still running sequentially on a file. But there is a small workaround how you can handle this. You can also do an RMAN-based encryption. Sounds a bit weird, but it's really nice, a nice way, because what you do is that you do a restore or also a duplicate as encrypted, and you start using multi-section restores for parallel processing. So this way you can use RMAN to run multiple sessions on one large data file. So that's really nice for very large thing. It can be run also on primary, on standby database, whatever. If you do it on a standby database, then you can even do it without the downtime. And if you do a lot of Herman sessions in parallel channels, then you can do it in parallel and speed it up. We did this for a customer. Now that's the next slide for the customer. Just here before we have the methods at a glance. So we compare it. We have the new tablespace, the online encryption, offline encryption, RMAN encryption. And it depends what you want to reach and how much downtime you want to have. I mean, the easiest way is if you have a medium-sized file, you can do an offline encryption, for instance, on a standby database, and then switch it over. That's really straightforward and easy. That's definitely without special effort. It's nice. If you don't have high IO bound load, then you can do also online encryption. It's also nice, and then it's quite simple. The RMAN-based encryption is a bit more complex, but it can really help you if you have a bigger issue or a bigger challenge, like we had it for a certain customer. we had a database, the whole database was around 150 terabyte, and the largest tablespace was a big file tablespace with a file up to 50 terabyte. And when we did an offline encryption of this particular data file, the first time on a test, it took 8 days. I mean, one thing would be that keeping this tablespace offline on production on the primary side for 8 days, that's usually an issue to take the database offline for 8 days. In particular, then is the data is probably not important and therefore also not required to be encrypted. So we did it on a standby side, but the problem on the standby, having a standby database which is out of sync for 8 days is then another issue, because then you have so much read logs which you have to apply that it takes again a couple of days to apply them and to be in sync again. What we did there is that we decided to do a standby first approach, and for the small files we just encrypt them offline. So it means all files smaller than 1 terabyte, we did an offline encryption of these files. And the larger files, we decided to make a backup on the standby side to the fast recovery area. We had around 250 gigabyte, a section size of 250 gigabyte and around 16 RMAN channels. As soon as the backup has been done, we cancel the standby recovery. So the standby was then offline, not synced anymore. We did a restore of this file, and then we resumed the managed recovery on the standby, and we deleted the backup. And this way, we could bring down the whole rollout of TDE from 8 days down to around 22 hours. So it was really a nice approach. It took a bit more time and preparation, but it was straightforward, and it's really great for large databases where you can use this RMAN-based multi-section backup and restores. Then something else, also this customer, we start to encrypt this 150 terabyte, and then after a week, a storage team came and say, hey, you are using much more storage. And when you say, it cannot be, there is no storage impact on the database. So a database has the same size when it's encrypted as when it is not encrypted, which is true from the database point of view. So the blocks of a database have the same size if TDE is in use or not. But the problem is that suddenly the blocks are filled with information. And this means that if I have a tablespace which is not encrypted, there are a lot of zeros and empty blocks and so on. And the storage system could optimize them and could reduce the effectively used storage size. But starting with using TDE, this deduplication doesn't work anymore. And then it can end up that the storage usage on this particular database is then not, it's then one-to-one, means that if it's 150 terabyte from the database point of view, it's also 150 terabyte on the storage system. And in this particular customer, they had, before TDE, they had, I think they had a relation 1:2, so it was half the size. So they could do a deduplication, and the storage effectively used storage size was half the size of the database size, and with TD it was then 1:1. So the storage cannot be optimized; it's then as it is. So that's one problem. For the backup, it's the same, but there you can use the storage compression. So not the storage compression, sorry, the RMAN compression, which then again you could compress the backups a bit more. This customer luckily had this option available, and then he started to use RMAN compression, and at least the backups could be compressed again by factor 4. There is a white paper on this called TDE and general purpose deduplication technology. So it's really a few technical insight on why deduplication does work or does not work anymore if you have TDE in use. But from the database point of view, the database is 150 terabyte before TDE and after TDE. It's just the storage level, which is a little bit different. Okay, then let's dive into the last topic. That's the key store. You probably can remember we had this key management, the standby database, and then move over the keys and so on. Or that's one thing. Oops. That's one thing. And the other thing is that probably you have tens or hundreds of databases which you encrypt, and then suddenly you come to the point that you say, I would like to have a central management of the keys, and I would like to make sure that my key stores are not hanging around on the database server. In the old times, you just had the option to use the hardware security module to store it in this appliance, and yeah, to use a central store for you hardware keys or master encryption keys. In the new modern times, there is also an Oracle option available called Oracle Key Vault, where you could do also the key management for multiple databases. This tool as well, it's an appliance. It is a software appliance, so you set it up yourself on a system which you decide how large it would be. And that's one of the points which is really important. We'll discuss this later on. And Key Vault can, beside the TD management, also manage other things like Oracle Key Vault, or Oracle Wallets, secure internal password store, credential, SSL keys, and also SSH keys for SSH logins on your system, for instance. It has all the functionality which you know from Oracle. It has an Apex-based web interface. It has the classic, it is backed by Oracle, RMAN backup in the background. It is protected with TD and database vault and so on. So it's really basically a hardened Oracle database in the background with a lot of features around it, if you want. The benefits of HSM and also Key Vault is that you have a segregation of duty, so the DBA cannot access the keys anymore. It's been easier to be compliant, and key handling is easier if you have a data guard environment or a rack environment, because they point to this HSM or Key Vault, and you don't move around keys. But we will see why the Key Vault is definitely a better option than the HSM in a few minutes. So here, just as an overview, the Key Vault architecture and a few features. So you can also set up Key Vault as a cluster, with active cluster, which is replicated. You can integrate other Oracle products like Golden Gate, also MongoDB. You can integrate your Azure-based autonomous databases, ExaDBs, ExaCC system, the engineering system, on-prem system. So that's all what you can integrate with Oracle Key Vault. We don't dive into this because this is another technical session, and which will be not, yeah, so I cannot do this within the next couple 5 to 10 minutes. But one really important thing is when we compare TDE with Oracle Key Vault is the interrupted chain of master encryption key. So the thing is that sometimes I have my keys. I do a rekey. I have an old key, then I do a rekey because I cloned the database. And the really problem is that a third-party key manager cannot maintain this continuous TD master key chain. So as soon as I do migration, they start to have a new master encryption key. And if I do a rekey, they have a new one. And the problem is then, depending what I'm doing, I lose the old master encryption key, and in certain situation I need them. In particular, if I do a restore of a backup, which has been done a couple of days ago before my rekey operation, so I need the old master encryption key, or if I do a migration and I need to do lifecycle management. So there could be a couple of things. But now, how does this interrupted chain of key management looks like? Here we have an example. We have on the left side a software key store, in the middle HSM, and we have a software key store. You see, we have the MAC, master encryption key 1, then I do a rekey, then I have 2 of them, I do again a rekey, I have 3 of them. So I have in my software key store already 3 keys. The master encryption key 3 is the main one, or the active one. If I do a migration, the HSM cannot copy this key. It will always create a new one, so the 4th, which is then stored. I don't know if, depending on the product, HSM also have then within its boundaries multiple master encryption key if I do a rekey. But in any way, if I then do a migrate back to software key store, I have then again a new master encryption key. You see, we have here we lose the history always. And if I have a backup which is done with the software on the software key store, and then an archive log backup which is done with ASSM, then I do a restore here at this time, I cannot access this old software key store because my system is then configured with HSM, and HSM doesn't know these old master encryption keys. And with the Oracle Key Vault, it looks quite different because the Oracle Key Vault, when I do a migration, it takes over the software key store. And if I do a rekey, it just adds a new one, multiple one. Every rekey operation creates a new one, and it keeps the history. And even if I go back to software key store, I still have my history in my software key store. So I can always go back to any point in time where I probably need this old master encryption key because I want to restore something from 4 days ago before I did my rekey. And that's the really main difference because it's really important to consider Oracle Key Vault in such situation. There are a few other things which are way too much or too complex now to finish within the next 5 minutes. That's other considerations like FIPS compliance. So there is one thing that if I want to be FIPS compliant, that I have limitation on HSM, and there are issues that I cannot set up high availability on HSM if I configure these non-extractable keys because they cannot leave the boundaries on one HSM, and with Oracle Key Vault I have different possibilities and I can do this. These are a few aspects, and then other aspects as well is performance and scalability. Oracle TDE is quite chatty. The database is always talking with the key store, the software key store, and in particular with the hardware key store. And it can happen if I have tens or hundreds of databases that the HSM gets quite a lot of requests from the different DBs, and I'm limited there with the performance. And Oracle Key Vault, it's at the end of the day, it's just a database. I just can run it on a larger system, on a larger physical system, put more memory in it, and then Oracle Key Vault is happy. These are a few things which I have to consider when I have a really large environment. Just here to highlight a few things. So Oracle Key Vault is not an HSM, so it's really different approach. HSM definitely provides physical tamper-proof key storage. Yeah, TDE is definitely optimized, or Oracle Key Vault is optimized for TDE. So really, these are a few things to consider. I have other things like life cycle operation, which is easier, cloning is easier, and so on. But the integration at the end of the day looks similar. I install corresponding libraries locally to allow the database to be integrated into HSM or Oracle Key Vault. So the last 3 slides, a few best practice. What's really important is that before I start with the whole thing, I should really start thinking about how should I do the key handling. I mean, I can start with keystore, but I should think about it. Do I have to implement the segregation of duty? Do I have to have a lot of systems? Do I have rack and data guard, and do I have cloning? So that's really something which I have to consider, and I have at least an idea and a plan how to use it. I mean, I can start with software key store, but as soon as the system and environment gets larger, it makes to have a central solution for the key management. Don't forget the backup. That's also really something important. Segregation of duty. It's nice to use SysKM and SysDBA, but to have a really proper segregation of duty again, then I start to have to use a solution like Oracle Key Vault. And then also lifecycle management. It's important that I plan this somehow and that I plan this carefully. So not that I mean, if I decided to not do a key rotation and I clone my database on a monthly basis, then the production database is cloned to the test system, and then I have a copy of my keys on the test system as well. And that's probably what I don't want, because I would like to have a different key on my test system rather to the production. So then I need to do a rekey on production and things like this. Yeah. And if you start think about this, then make sure that you also consider all things, not just TD, because it's really best to integrate it with proper auditing, with a database hardening, central user management, and so on. So these are really important thing to consider when I start to implement database security. So it's this layered approach, start to use different things, different stuff to make your database secure. Yeah, so to conclude, to come to the conclusion, TD is definitely a matter and flexible. It's not plug and play. You have to really think about a few things. You have to think about the keystore and how you handle this. And if you know how to handle this, then it's really easy to implement it. If it's a larger database, yeah, you have to implement. You have to probably invest a bit more in the deployment and planning the deployment. But the really important thing is that you have to know how you handle the EU keys, and then it's quite simple and easy. And an important thing is test your use cases before rolling it out in production. So if you have a cloning, set up a RUC, set up standby database, so do a few tests on this with the database. To do the test, you don't need a large standby database. You don't need to do a large database cloning. It's enough if you have a simple, small database, but do this different test before going to production. Then you have approved use case and operation use cases. And also, if you want to play around, there are plenty of live labs around for this, for TD itself, but also for Oracle Key Vault. You can look into it, you can play around, set it up, and then you get started before you start to work on your environment. And I would say start with a live lab, and if you're ready, start to test it on your environment, and yeah, then it's easy. Here you also find a couple of notes, which I mentioned during the presentation, and the white papers. And I just check, I see at least 2 questions.
Yes, thank you very much. We're just in time. Maybe you can take one of the questions if you can. Do you want to read it out loud for those who?
Yeah, I'm just reading.
Okay. With 2 more minutes to go, and well,
Yeah. Well,
the answer, I want to make sure I have the time to thank you
it's a quite complex question. But at the end of the day, with a standby database and so on, at the end of the day, the file can be different on standby database and primary database, but the contents or the master encryption key must be the same. So I can have, on one side, I can have the key store in ASM, and on the other side, I can use it file system based. There is a admin key export and import command to export and import the master encryption key. So theoretically, I can have 2 different key stores and export and import it. So this admin key management, but
all right. Well, with that, we need to wrap up. We'll make sure to take all the questions and have Stefan look at them and answer them. And if possible, we'll include the answers in the email with the replay that we'll share in the next video. So thanks again for joining us today. A big thank you to our speaker for such valuable insights and practical guidance. We hope you found our session both informative and inspiring. And we're looking forward to seeing you to our next ACE Live session that's scheduled on December the 3rd. Have a great day, everyone, and thank you.
Thanks. Bye, guys.